The last section of chapter 14 on reaction rates is about catalysis. A catalyst is a material that allows a reaction to proceed much faster than it normally would. A catalyst is a substance that is not used up in a reaction, so it doesn't undergo a chemical change. But what it does do is it lowers the overall activation energy for a chemical reaction. That's one way it could operate. The other way it could operate is by increasing the number of effective collisions. Okay, so what does effective collisions mean? Effective collisions means essentially that we have collisions with the right energy and orientation. So as we talked about molecules, when they react, the atoms that are going to be forming bonds or breaking bonds, they have to be in contact with each other. So in those cases, they need to have, that means they have to have the right orientation. So what a catalyst does is that it provides a different mechanism for the reaction. So we often see a catalyst as a reactant, and then in the first step, and then a product in the final step. So here. So the decomposition of hydrogen peroxide does not occur very quickly. It's a slow process. It is exothermic, as you can see by our reaction coordinate diagram, our reaction progress. But we would have a reaction progress diagram that would look something like this for the uncatalyzed reaction. Here what we can see then is that when we add a catalyst, the reaction coordinate diagram changes. So when we add, for instance, in this case, hydrobromic acid, which completely dissociates to form H plus and Br minus. This acts as a catalyst for the decomposition of hydrogen peroxide. And it occurs in a couple of steps, okay? So here we have our new reactants. We have a new reaction coordinate diagram with a different activation energy, a lower activation energy, and then the products. And you'll notice that in the reactant side, we have 2 Br minus and 2 H plus, and in the product side, we have the same 2 species. That is because they are not consumed in the reaction. That means they are a catalyst. So there are enzymes which are a specific type of biological catalyst. Most of the time enzymes are large protein molecules, and they can catalyze only very specific reactions. The way we talk about enzymes is that an enzyme catalyzes a reaction at its active site, and the substance that undergoes the reaction at the active site are called substrates. So here we have an enzyme, we have a substrate, they sort of fit together and allow the reaction to take place and form products. So the one thing that you'll notice is the shape here. Now obviously these are just some geometric shapes we've drawn to sort of provide an example for what this may look like. But the shapes are complementary. Okay, so the substrate has to be able to fit into an enzyme pocket. That substrate enters into that pocket and the products move away from the site after the reaction. Then you can have more substrate come in and more products leave. Now if we have a substrate that bonds to the enzyme so tightly that the products don't leave, the active site is blocked and the catalyst no longer works. And if you are interested in how some poisons work, essentially what they do is they come in and they block the enzyme by binding to that active site and don't allow the reaction to take place. So just a summary slide here of catalysts and the way that in which they work. So just a reminder, the catalyst provides or increases the rate of the reaction. It doesn't undergo a chemical change. It provides a different mechanism for the reaction that has a lower activation energy. Okay. It allows for the proper orientation and energy. It improves the effectiveness of the reaction. Right? And we talked about catalysts and what they do, so you can take a look at this slide to just sort of get a summary of this section of material.